Welcome, it's our flip book and I'm here to do the even problems. So let's get started. Alright, so number 2, our proof here, it says B is the midpoint of AC. So the first thing to do is mark your picture as best as you can. Remember, midpoint right here is a key word for us. It's going to let us know that sides are congruent. So if B is the midpoint of AC, that means we're going to get a congruent segment of AB and BC. And it says AD is congruent to DC. And then we have our third side there. So this is by side, side, side. We know the reasons already. They're right here. So we know it's side, side, side. So let's go ahead and jump into our proof. Let's throw in AD first is congruent to CD, and that was given. And we just proved a side. Now we have to prove 2 more sides. You have to say B is the midpoint of AC, and that was given. And that does not prove a side. I wanted to put an S there, but I actually didn't write anything being congruent here. So I have to actually write what was congruent from that, which is AB is congruent to BC. So that was definition of midpoint. When you have a midpoint, it cuts a segment into 2 congruent parts. Now I can put a side. I got really anxious there. Last but not least, we see DB is right there in the middle. So DB is congruent to DB, and that's reflexive property. What a good strategy would be is to start studying the different pieces that happen often. Reflexive happens a lot. Midpoints happen a lot. And when you see a midpoint, it's a segment that's going to be congruent. If you see reflexive property, it's a segment that's congruent. Okay? And then we get triangle ABD is congruent to triangle CBD by side, side, side theorem. Okay, there you go. Next one. All right, here we go on our side angle side. M is the midpoint. Again, there's that key thing, midpoint of LP. So here's LP. So M is the midpoint, so it's going to cut that into 2 congruent parts. But it says it's also the midpoint of NO, so these are also going to be congruent here. And then the other thing I see is the vertical angle, which I'll mark right here in pink. And we have side angle side. And we know it's side angle side because this angle is included. It is between the 2 congruent sides. Okay? So we'll go ahead and start out. M is the midpoint of LP and NO. That was given. It didn't actually prove any side, so I can't put an S onto the side. But what we can do is we could say LM is congruent to MP. That's these 2 segments right here. And that's by definition of midpoint. Now I can do the angle next, or I can prove the other side. Doesn't matter. Since I talked about the midpoint already, let's go ahead and get the other side, which is going to be NM is congruent to MO, and that's by also definition of midpoint. And the last thing I have to prove is angle. Again, the order can change. It doesn't really matter the order in the proof. It matters the order in the picture of why I have side angle side versus angle side side. Okay? So we can't write angle M, so we have to use M as the vertex, so it's going to be LMN. Angle LMN is congruent to angle... Sorry about that. So angle LMN is right here, and then we have angle OMP. Angle OMP. And that is vertical angles. We proved all the pieces, so we can now say that the triangles are congruent. By side angle side theorem. Okay. Next is cruising for a bruising, and this one is a beast of a proof. C is the midpoint of AD. That means we're going to have this segment is congruent to that segment. AB is parallel to CE, and BC is parallel to ED. Okay, so I have one set of congruent sides already. but I also have some congruent angles. Whenever you see parallel, think of congruent angles. So these pink guys right here are congruent because they're corresponding. And these yellow guys are also congruent by corresponding. So we actually have angle, side, angle. The side's included between the two angles. So we're going to start with some of our given information. C is the midpoint of AD, given. Didn't prove anything, so I'm going to prove it now. AC is congruent to CD, and that was by definition of midpoint. Okay, so I've taken care of the side. Now I have to take care of the angles. Well, I have to state these. So I'm going to have to do AB is parallel to CE. That was given. Since AB and CE are parallel, it makes those pink angles corresponding angles. What you can do is you can kind of continue the lines to make it easier to see. And if I were to draw a little circle here, and I were to draw a little circle here, you see they're both in the corresponding spot of that table. Okay? So those are corresponding angles. So we can call this just angle A is congruent to, now I can't say C, so I have to say ECD. And those are congruent by corresponding angles. And we can throw on theorem. Okay, so that proved an angle. And then we have to say BC is parallel to ED. That was given. And that gives me the yellow angle. And again, if I continue these on, the yellow is in the left top, so those are also corresponding angles. Here I can call this angle D, but the other one I have to call BCA. Angle BCA. Notice C's in the middle, B and A make up the sides. And that's corresponding angles theorem. That proves all my pieces. I have the angle, the side, and the angle. And so now we can say that the triangles ABC is congruent to triangle CED by angle, side, angle. All right. Finally, they gave us a shorter one. How nice of them. Okay. Well, kind of short. It's 5. I guess that's short. TV bisects. All right. The word bisects, obviously we're going to have some congruent things here. It bisects CVU. That means this angle and this angle are now congruent. And then it says TSV. TSV is congruent to TUV. And then they share a common side right here. So this is angle, angle, side. The side is not included between the angles. It's right over here, otherwise it would be here. So we can go ahead and put this down. So let's start with our first given. TV bisects angle SVU. That was given. It didn't prove anything. It just shows that we can make proof in the next line. SVT, so angle SVT is congruent to angle UVT. And that's by the definition of bisects. Bisects means it cuts into two congruent parts, and those are my congruent parts. So this angle SVT is right there, and this angle UVT is right there. Then we have TSV is congruent to TUV. Sorry, that proved an angle. This is given to us, so that's an angle. And then we know TV is congruent to TV because of reflexive. That's side. And we got all 3 of our pieces again. The order over here doesn't matter, it's the order in the picture that matters. We get TSV is congruent to triangle TUV by angle, angle, side theorem. And our last one. Okay, 5 steps again. They are right triangles. F is the midpoint of DG. So if F is the midpoint of DG, that means these segments are congruent. And DE is congruent to GH, and the 90 degree is right here. And on this one, where do you put the 90 degrees? It's kind of hard to say, but normally it's going to be from the middle right there. But also kind of look at the picture to see where would a 90 make most sense, and it's probably where it looks like it's perpendicular. So that one you kind of have to go off of that perpendicular piece. Normally I like just to give you that. So we do have to say that we have right triangles, so we have to give that first statement up. DEF, oh, by the way, I'm sorry, this is HL. The hypotenuse is here. It's across from the 90, so this is the other hypotenuse. And this is a leg. Both of the other ones are called legs. Okay, so we have legs and hypotenuses. So DEF and triangle GHF are right triangles. That's given. Okay. Next, F is the midpoint of DG. That was given. I haven't proved anything yet. And then DE is congruent to GH, which is, believe it or not, given. And that's the first thing I proved. Now normally I put an S, but we're using a right triangle, so I'm going to actually call this the L. I'm sorry, yeah, that's the L. But we know that since F is the midpoint of DG, that we know that DF is congruent to FG. And that's by definition of midpoint. We could have put that in a different order, it doesn't matter, but that's your hypotenuse. So now we can say these two triangles are congruent by HL. Hypotenuse leg. Alright guys, thank you so much for sticking around. Have a good one.